Right, the equation of a circle centered on the origin is x squared plus y squared equals r squared, where r is the radius. So in this case, we can just look across, r is equal to 10, and therefore x squared plus y squared equals 10 squared, which we should write as 100. And that's our answer. Very quickly, where does that come from? Well, it comes from Pythagoras' theorem. If I had a point on my circle, then I've gone along x, I've gone along y, I can see I've got a right angle triangle, I can see that x squared plus y squared will equal this length squared, but this length is fixed throughout the whole of the circle. So if I do a triangle over here instead, then I'd get a different x, a different y, but I'd still get this r squared here. So you can see it always works. Right, good. Point P has coordinates 8, minus 6. Show that point P lies on the circle. We can substitute into the equation and show that this is true. So 8 squared plus minus 6 squared equals 64 plus 36 equals 100, which is what we want, remember? So P lies on the circle. Good to just give a conclusion. That is enough. Another way you could do this is you could just take this equation, substitute in the x value, and find both y values that go with it. So when x is 8, you'll get y squared is 36, so y would be plus or minus 6, and p would. On it, I think that's just a little bit more complicated though and unnecessary. It's fine to just show that the equation is true. Find the equation of the tangent to the circle at point P. Right, let's get P on the circle. So 8 minus 6 can be moved down here. A tangent is then a straight line, draw it in green, that just touches the circle. So something a bit like that. And that tangent is going to have equation y equals mx plus c because it's a straight line. The question is, what's c going to be? It's going to be down here somewhere. It's going to be less than minus 10. What's the gradient going to be? Well, we don't have an obvious rise and run at the moment. Or do we? This is where something comes in. Basically the normal comes into this. You have to do that for this sort of question. If we draw the normal, then first of all, that is at 90 degrees to the line. So what we're doing here, why have I started drawing the normal in? We're going to be using the fact that gradients of perpendicular lines have a special relationship. So if we can work out the gradient of the normal, we're well on our way. And we do have the gradient of the normal because I know I go 8 along and minus 6. I go 6 down. So the normal gradient is equal to rise over run minus 6 over 8 or minus 3 over 4. So tangent gradient right, now the relationship, I've not spoken about this yet, is that if two lines are perpendicular, then the gradients actually multiply to give minus 1. You can prove this using a similar triangle argument, but it is a fact that needs to be known, used often at A level as well. What that means is to get the gradient, if you have one of the gradients, is you can just do minus 1 divided by the gradient that you have. So it's going to be minus 1 divided by minus 3 over 4. Well, first of all, the negatives cancel, and secondly, I can keep change flip, so it'd be 1 times 4 over 3, and we're going to get 4 over 3 as our tangent gradient. We're nearly there now because I've got that y is equal to 4 over 3x plus c. I've worked out the gradient. Now I can again use the fact that it goes through 8 minus 6. So it must be that minus 6 is equal to 4 over 3 times 8 plus c. You know what, I expect this to come out a bit nicer than it is, so I'm going to need to work out what 4 over 3 times 8 is 32 over 3. And then I'm going to have to add, do minus 6 minus that answer. And that's going to give me minus 50 over 3. And that's looking about right, to be honest, for my drawing. So minus 16 and 2/3 I'm going to write it as. And therefore my final answer is going to be y equals 4 over 3x. As horrible as this is what it is, minus 16 and 2/3.